Okay, so hi guys. Now we're moving on to the next thing. Linear transformations from V into V. Okay, so in some cases, the vector space that you're transforming into W is the same thing as V. Okay, and therefore the basis C is the same as B. And when this case happens, this matrix M has a new notation and a new name. M is now called matrix for T relative to B, or simply B matrix for T, and is denoted in this way, okay? And this is the notation that defines the case where W is the same as V, okay? Let's move on to example. Yeah, let's move on to the example. So you have a transformation from P2 to P2, and the transformation is a derivative. You put something into the transformation function, and what comes out is the derivative of whatever you put in. So they want you to find this B matrix for T, and they give you the basis is 1, T, and T squared. And they also want you to verify the condition 5 right here. So what happens, right? Well, you know the basis vectors in terms of the original, in terms of whatever you put into the transformation function. So what you do is you transform the each basis vector, right? 1, T, and T squared. So out you get some results out, and the trick is, look, originally the basis vectors are defined with three elements of a vector, right? You have three, because there's three terms right here, 1, 2, 3, but out you get there's only two terms, 1 and 2. So what happens once you do the transformation? These first two rows might be non-zero, but this third row is always going to be 0, because look, there's only two terms, okay? So yeah, so T of 1 is 0, so everything is 0. T of T is 1 is a coefficient, and coefficient corresponds to this part right here. So that's why it goes right there. T of T squared is 2T. It corresponds to this one, so it goes in the second entry. Once again, there's no third entry, so this third row is always going to be 0. Once you put these into a matrix, you get T sub B equals that. Okay, so they give you a general P of T function right here. So once you do a transformation T of P, see the basis from the original to the transformation is the same. You get this result right here, and this result is equal to the matrix that you found in the last part, which is the T sub bracket T sub B matrix times the original coordinates. Okay, the original coordinates are bracket P sub B, and see, this is a visualization of that. Once again, this is always going to be 0. So now I want to move on to this stuff, and this stuff is even more tricky. Diagonalizing A amounts to finding a diagonal matrix representation of X to AX. Suppose A equals P times D times P inverse, where D is a diagonal n by n matrix. If B is the basis for Rn formed from the columns of P, then D is a basis matrix for the transformation X to AX. What this is saying is, look, if you have A, right, and you can diagonalize it, then in terms of the base, and if you look at the P matrix, right, if you think of the columns of P as a basis for Rn, then what D is a transformation is a matrix that will define this transformation right here. That's a very tricky idea. I want to reiterate this again. If B is a basis for Rn formed from the columns of P, in other words, if the columns of P is a basis of models Rn, then this D right here is the transformation, models a transformation x to Ax. Okay. Here's an example. Here's a transformation. You have A equals this guy right here. What they want is find the basis B for R2 with the property that the B matrix for T is a diagonal matrix. So what happens after you diagonalize it, the columns of P are denoted B1 and B2, and they're eigenvectors of A. And the important thing is right here. By theorem 8, D is a B matrix for T when B is B1 to B2. So in other words, when the basis vectors are these guys right here, the transformation is this diagonal matrix. Okay, so when you do x to Ax and u to du, they're describing the same thing, but in terms of different basis vectors. Okay, I think I'm gonna stop right here because honestly I don't feel very comfortable explaining this part theoretically. I'm just gonna leave that to you because I think in general you shouldn't watch my videos just to get by. You should read this yourself because that's really when the conceptual understanding is gonna happen. The video will help, but it won't show you everything. Okay? Thank you.